Chapter 9, Inheritance and Interfaces, Part 6. So the instance of operator can help us determine the type of the object before we attempt a downcast. Because if you try to downcast an object into a class reference of which it is not a member, that is, if I try to downcast a bank account into a car reference, it's not going to work. I am going to get a class cast exception. A class cast exception occurs when you try to cast a reference, into a type of which it is not compatible. So we can use the instance of operator to determine if the reference is referencing an object that's of a particular type of instance. For example, in the gray box, if obj instance of question. So that means if the reference obj is of type question, if it's referencing an object of type question, then go ahead and do the cast. Question Q equals downcast to question obj. So instance of will test, it'll return true or false, it will test whether a particular reference is referencing an object of a particular type. Here's an example. Using the instance of operator involves casting. So it will return true if we can safely cast one object to another, or false if it cannot. Casting allows us to use methods of a new object, and most often used to make a reference more specific, so going from a general to a specific. We can cast an object reference to a more specific class type as needed just in the last section, the last lecture. So if an object, instance of question, if an object refers to an object that is of type question, then we can go ahead and do the downcast. Otherwise, we would wind up with a class cast exception. So why does system.out.println, system.out produce a result such as java.io.printstream at 7a84e4? Because the implementer of the printstream class did not supply a toString method. So in the printstream class, there is not a toString method. Therefore, it's calling the toString method that is in the object class. So that's why it just prints out with the name of the library where it is and the class name and then the address. Will the following code fragment compile? Will it run? If not, what error is reported? Object obj equals hello. So think about what's going on there. When you have the string constant or string literal hello in double quotes like that, that is essentially creating a string object. So object obj equals, and hello would be a string object. So reading from right to left, string is a object that passes the inheritance test. That is perfectly legal. So let's go ahead and look at the next line. System.out.println obj.length. Well, we know that there is a length method inside the string class. However, obj is an object reference and there is not a length method inside the object class. So the second line will not compile. It would work if we downcast obj to a string before trying to dereference the length method. Will the following code fragment compile? Will it run? If not, what error is reported? Object obj equals, who was the inventor of Java? Again, string is a object, so that works. Question Q equals question obj. Can we downcast the obj reference into a question? Well, look at the line above. Object obj equals, double quote, who was the inventor of Java? Close double quote. That's a string, not a type question. So when we attempt to downcast obj to a question reference, it's not going to work because who was the inventor of Java is a string and not a question. And then q.display won't work because of the problem in the line above. So the code will compile, but the second line will throw a class cast exception because question is not a subclass of string. Why don't we simply store all objects as variables of type object? Well, we could do that. In fact, those of you who've coded in JavaScript know that, or actually, gosh, what was it? I think it was an early version of Visual Basic, it made everything this data type called variant, which was just kind of this amorphous blob that was a mess. People got very sloppy with their coding. JavaScript also allows you to make all your variables vars, which isn't a data type. It's just kind of this generic whatever. We could, but there's only a few methods inside of object, and it would be extremely restrictive if we tried to do that. We wouldn't be able to get any bank accounts or savings accounts or anything. And so yes, but horrible would be a bad way to go. Assuming that X is an object reference, what is the value of X instance of object? The value is false if X is null, because X would not have an object if X is a reference, but it didn't tell us what it was referencing. So if it's null, it's going to be false. Otherwise, it's going to be true, because if true actually is referencing an object, then all objects are of type object. They are all ultimately objects. So try to avoid doing type tests. Okay, if we say if Q instance of choice question, to do the choice question, else to do the question, it's a poor strategy given that if we add other question types, fill in the blank, essay, etc., we're going to have to go back and make specific modifications to our code. So we want to make our code as robust and adaptable as possible. That's another reason why you don't hard code the end of your arrays. Like if you're writing a loop, you would say for int I equals 0, I less than array.length rather than 5, for example, because it is very restrictive and you'd have to make a lot of modifications to your code if you updated the size of the array. Similarly, if we updated the questions that we were using, the class questions that we were using with this, that would present a problem. So we want to let polymorphism use the correct method. So if we declare a do the task in the superclass, then we can override it in the subclasses, and we can just use a loop, and we don't even need to ask if they're instance subs, because we won't need to do the downcast. So you might have encountered this in your bank account, savings account, checking account program that you're working on. And if you put your compare to in bank account and you put your compare to in savings account and checking account, similarly with the equals method, you can just use polymorphism and you don't have to worry about downcasting, and you don't have to worry about the method not being in the superclass during compile time. So it makes your life a little easier, and it makes polymorphism do all the hard work. So inheritance and the toString method. Instead of writing the type of the object in the toString method, we can use the getClass, which is inherited from object, in the superclass. So we could say, assume we're using public class bank account, public string toString, we could say return getClass dot getName. So that would be the class name, which would make our code a little bit more flexible, and then returning the balance. So then when we're using inheritance, we could put our call to toString, super.toString first, and say super.toString, and then it would print out the class name, and then balance equals balance, and then interest rate equals int rate. That's good if you want to use the class name with it, but we haven't been doing that in our programs, and getClass is not part of the AP subset, so you don't have to worry about it too much. Let's talk about the equals method, which is part of the string class, is part of the AP subset. What if someone called stamp1.equals x, where x was not a stamp object? Using the instance of operator, it would be possible for other object to belong to some subclass of stamp. So we could use the getClass method to compare the exact class with the past object, just to make sure. So if we say if other object equals null, return false, it means there's no other object to compare it to, so don't even bother. It's really a good idea to check for null first thing in your method so that you don't run into exceptions later on because you don't have any object. That's a super good idea, and that's something you will see on the AP exam. If getClass does not equal other object.getClass, so if they're not of the same class, then we return false because they aren't going to be equal to one another if they're not of the same class. Note that when you return, you're gone. Your method is over. So we don't need any else's in this method because if we return false, we're done. The only reason we get to the next line of code is because it was not false. So stamp other equals stamp other object. So then we've already ruled out any other class type. So we can downcast it to a stamp and then return color.equals and so forth.